one. Hello guys. In this tutorial, we need to find the reaction at the support, and we also need to determine the forces through the hinge at C. So at C, there is an internal hinge, which is Cx and Cy. So at C, there is an internal hinge which represents Cx and Cy. Okay, Cx. This is called frame. This is frame part, and this is also the frame part. So we can use to disconnect the part into two. So let's call this part 1 and this called part 2 of CDE, and 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 part A is ABC. Okay, so support A, it has how many loads? Pin. It's contained with AY and AX, and EY also contained with two reaction at pin EY and EX. Okay, so how many for unknown force do we have? 1 2 3 4. So 4 unknowns, okay, is equal to, we have three equations, which is summation of the moment. We can solve the summation of f of y, summation of f of x, plus we have the one, which is the hinge. Okay, so right now we could solve the structure. Remember, we could solve the reaction of the structure member. Okay, so it is equilibrium. Right now it's statically determinate. We could solve it, so it's called statically determinant. Okay, so we can solve the structure easily. Okay, uh, but we need to disconnect. Okay, we need to disconnect at C, since C is hinge, and we know that hinge, we need to disconnect. So we disconnect with the least number of unknowns to start with. Both they are the same, so AX and AY and EY and EX. So when we disconnect at C, we are left with CX and CY. So this part we are left with let's say this is okay. Oh, sorry. Okay, let's try to draw it here. Sorry. Okay. This is B and this is C and this is A. Okay, and you have CX, you have CY. Okay, at A, and also you have the structure member at E. Okay, E. I need to tell you something most important. CX, D, and C at C. Okay, at C, 5 kilonewton is the external load. I can put it here or here. Let's put it here. Okay, 5 kilonewton, and CX, we need to also, this has an internal due to the same magnitude but opposite direction, the internal load, and CY is downward, so therefore CY is upward. Okay, so I need to find the structure of CY and CX for part 1. Okay, and I need to find the structure of also CY and CX for part 2. Okay, I don't need AY actually. AY and AX I don't need right now, and EX. So since I found the structure of CY and CX, and from here the structure I can find CY and CX, so my life right now it's easy. I can find the force at CX and CY, and I can from here I can find AX and AY, and from here I can find EX and EY. So start with finding the moment opposite to the hinge right now, since we have 4 1 2 3 4, since we have 4 1 2 3 4, part 1 4 unknowns, and part 2 we have 4 unknowns 1 2 3 4. Okay, so uh, let's the step we need to do, let's find the moment at A. Okay, we need to find moment at A in order to find Cx and Cy, and we need to find the moment at E plus usually plus in order summation moment at E equal to 0 in order to find Cy and Cx. Once I found, I will relate both of them with making mod phi 1. So I will find Cx here, I will put it, and Cy here, also here. So there I can find summation of f of I and summation of f of I to find Ex, and summation of f of x to find Ey. Summary goes with this one. Okay, so let's start. I will erase everything. Okay, I will erase everything. Really love my eraser, just goes with this one. Okay, let's use so huge. Okay, make it life easier. Okay, let's make it from this point. Okay, okay. Right, and let's start. Okay, so you have the first part. Let's try to draw it clear. Okay, you have the first part. Okay, first part, you can put it over here. Okay, so you have the first part, it's upward, and you have the downward. Okay, line A here, you have here A Y, and you have here AX. Okay, so look guys here, this is called 20 meter, and this is called 10 meter. So what will be the hypothesis? By saying square root 10 square plus 20 square, it will be the length of BC is 10 square root 5 meter, and 2 kilonewton per meter multiplied by 10 square root meter to be concentrated. It will form, actually for me it will form a uniform. Okay, perpendicular should be 20 square root 5 kilonewton. Okay, and here we have C, and as we said that when we disconnect it will result with Cx and Cy. Okay, you can add the 5 kilonewton. Okay, I will add it here. Okay, but only one time. Part 1, 5 kilonewton. So this is part 1. So I added 5 kilonewtons only one time. Okay, okay, so we have Okay, guys. In this point, we said that sine theta is y. Okay, so when we take the force and we resolve it horizontally, so this is the force, we resolve it horizontally, so we will take 20 square root of 5. Okay, so 20 square root of 5, and we need to take we need to resolve it. So instead of doing theta in frame, these two, okay, only in frame, only in frame. So in frame, we will take the vertical part, which is sine theta, the y, okay, horizontally. So when we resolve horizontally, we will take 10 as our target. And when we take the vertical bottom, when we resolve the force, we will take the cosine theta, okay, cosine theta, which is 20 kilonewton, okay. This will be 40 kilonewton, and this will be 20 kilonewton, okay. So let's erase this, okay, because we resolved the force, okay, so no need. Okay, and we'll also resolve this one, okay. Okay, I will remove this thing, okay. So it will be 40 kilonewton, okay. And as you know, the 40 kilonewton, it is half. So this, all of this from here to here is 20 meter, and it is at the middle, so it will be 10 meter and 10 meter, okay. Okay, so we need to find summation of moment at C, okay, equal to 0. So no, sorry, at A, in order to find the internal force at C. So summation moment at A. So we need to find Cy. Cy, it's going counterclockwise, so minus Cy time by 20, or from here to here is 20 meter, okay, perpendicular distance, okay. And we have Cx going clockwise plus Cx equal to 30 meter, okay. And we are left with the 20 kilonewton, which is minus 20 kilonewton, which is counterclockwise, okay, 20 kilonewton. And we remember that this distance is 10 meter, the half of it is 5 meters, so 5 meter, okay, plus 20 meter, which is 25 meter, okay. And we are left um, with the 40 kilonewton, so it's going with counterclockwise, 40 kilonewton time by 10 equal to 0. So let's do it in calculator. Minus 20 time by 25 minus 40 time by 10. So our answer will be negative 20 Cy plus 30 Cx equal to 900, okay. So this is our equation 1. Let's do the other part, okay. Disconnect with the other part. So when I do disconnect, sorry guys, let's use a ruler, okay. No, what, Okay guys, okay, so here, oh sorry, we didn't add the 5 kilonewton. We need to add the 5 kilonewton. Okay, I didn't add it, I need to add it. Okay, so let's add it, 5 kilonewton. Okay, so it's counterclockwise minus 5. Okay, minus 5 kilonewton, since we go like this. Okay, time by its perpendicular distance, which is 30. Okay, so minus 900 minus 5 times by 30, which is, change this into 1050. Okay, and here's at C, here's the point. We need cx. Okay, cx to the right, we need to make it to the left. Okay, to the left, cx. That's upward, cy, we need to make it cy down. Okay, and here do we have like e, there is ey, and there is ex. Here we have 20 meter, here's d, here's 20 meter, here's also 10. Okay, 10 meter. Okay, summation of moment, you can solve it. Summation of moment at e clockwise plus equal to 0. Summation moment at e, so cx counterclockwise minus cx, since it is counterclockwise, time by 10 meter plus 20 meter, which is 30 meter. Okay, and you have a force which is downward. Okay, remember this is force is downward. You need to find its perpendicular, which is 20 meter. Okay, this force is downward. It's going also counterclockwise, cy time by 20 meter. Okay, and it's equal to 0. So minus 20 cy minus 30 cx equal to 0. We need to try to make it linear. Okay, we need to try to make it linear as possible. Okay, so we take these two equations and by using the calculator, mod 5 1. So mod 5 1 minus 20 plus 30 1050 minus 20 minus 30 0. So cy will result for me negative 26.25. Cx will result for me 17.5. I need to put kilonewton. Okay, so where can I find, so cy, I need to change its sign convection. Okay, by changing its sign convection, it should be upward. Okay, this one should be upward. By changing, should be this one downward. This one should be downward. Okay, so cy should be downward. This one should be upward. Okay, so cy is equal to 26.25 and cy is equal to 26.25, while cx, the sign convection, is 17.5. I don't have space to write kilonewton, but 17.5, and cx over here is equal to 17.5. Right now you can find the summation of moment at A and at B. Okay, right now you can find the summation of moment at A and at B. Okay, summation of f of x equal to 0 plus, you have 17.5, so to the right side it should be 17.5, so minus ex minus 17.5 equal to 0. Ex equal to minus 17.5 kilonewton. this should be to the other side, okay? To the other side. The other side should be equal to 17.5 kilonewton. Okay. And we need to find the summation moment of f of phi. Summation moment of f of phi equal to 0. Upward positive. Okay. You have cy, which is 26.25, and you have the plus ey, which is upward also. Okay. So there's no any other force. So ey is equal to negative 26.25 kilonewton. Okay, where it ey equal to 26.25 kilonewton should be downward. Okay, downward. So we need to change it to downward, Okay, 26.25 kilonewton. Okay. Okay, guys, everything is on right now, and we are left with doing ay. Okay, let's change the color actually. Let's make it green. Okay. So summation of moment of Fy equal to 0 upward for this part 1. Okay, let's make it this part 1. Okay, this is part 1. For part 1, summation of Fy is Ay upward plus 40. Okay, plus 40. You have here Cy is downward, which is negative 26.25 equal to 0. So we will figure it out with 40 minus 26.25 will be ay equal to negative 13.75 kilonewton, where ay is equal to 13.75 kilonewton downwards, since our assumption is wrong. So it should be what? Downward. Okay, as it's mentioned, 13.75 actually. Yes, 7.75. And ex by using okay, this is ex summation of f of x equal to 0. Right side is positive. Okay, here we have minus 20. Here we have minus 5. Okay, minus 5, since go with this direction. Here you have plus 17.5. Let's go to the other direction. And here we have plus ax going to the right equal to 0. So minus 20 minus 5 plus 17.5. So ax equal to 7.5 kilonewton. Okay, guys. So ax is equal to 7.5 kilonewton, and our assumption is correct. Kilonewton. Okay.